All right, let's begin. Of course, as usual, we're going to begin with some definitions, and I will tell you exactly what to highlight or what to write down. Okay.
That's a lot of stuff to write.
So we've got 4 definitions. Take 5 minutes to write them down. Take 5 minutes, no more. Say that again?
It's inverted if you're for reflection.
Yeah, it's inverted. And you want to think about where is the middle line? Where is the symmetry line? What is it flipping over?
Can you repeat that question one more time?
Yep, I want to know. This is a reflection, and we can tell because it sort of looks like it flipped over. What is it flipping over?
The other points? Oh, wait, the pre-image?
What is it flipping over? If you imagine like if you're literally flipping a pancake, and you start from here and you end up here, where am I flipping over? What's the line that is dividing it in half?
Oh, the y-axis?
The y-axis, exactly. The y-axis is my...
Basically a mirror?
It's kind of like, yeah, where the mirror happens. And so what we call this is like the line of symmetry. You might also see it as the line of reflection or the reflection line. Either way, it's the line that is cutting it in half, and it's the line that it flips over. So here it's saying the transformation is a reflection across the y-axis.
So the y-axis is called line of symmetry.
That's your line of symmetry, yes. Now, notice how, if I want to see what happened to go from my pre-image to my image, I started out where, let's look at point T. How far away from the y-axis, from the line of symmetry, is point T? Four units to the right? To the left, good. So from the y-axis, I would go 1, 2, 3, 4 to get to T. How many units to the right do I have to go to get to T prime? Also
Wait a
4.
second, I'm confused.
So I would go 1, 2, 3, 4 to the right. So everything that you see on the left happens on the right of that line of symmetry. So if you didn't know the rule, but all I said was reflected over the y-axis, but it didn't give you a rule, all you would have to do is count how far are you to the left and then reflect that on the right. So if I'm 4 units to the left, this is going to be 4 units to the right. Looking at point S is 1 unit to the left. So S prime is going to be 1 unit to the right. Same thing with point R. Point R is 1, 2, 3, 4 units to the left. So my R prime is going to be 1, 2, 3, 4 units to the right. And I came up with the same exact thing I had before. So a reflection, the line of reflection tells you exactly what to do on the other side of it. When you look at the left side, you count how many units away you are from the line of symmetry. You're going to copy and paste that on the right side. Does that make sense? Can I get thumbs up or thumbs down? Good. See a lot of thumbs up. That's good. Don't overcomplicate it, guys. It really is as simple as what you see in front of you. So don't get too caught up in all of the ways that it's being explained. Just look at the picture and see the patterns in the picture. All right, we're going to do one more. This is going to be a dilation. So dilation is another way of what we saw before, which was enlargement. So enlargement can also be called dilation. I don't know if you guys have ever, if you go to the eye doctor, they dilate your pupils. That's where they make your pupils really big. That's called they dilate your pupils because that's exactly what dilation means. It means it's making them bigger. And it could also make it smaller, just like Alejandro just said. All right. So again, don't worry about this middle section. So just write down the pre-image, the image, and the rule. So let's look at our rule. My rule tells me that I'm going to multiply the x coordinate by 2, and I'm going to leave the y the same. So let's go ahead and do that. First, it's asking me to actually give the points. So let's start with J. Look at the graph. Where is that point?
Just J.
Just J.
-1 and 2.
-1, comma 2. Good. How about K?
Comma, 2, comma 2.
2, comma 2. Nice job, Eric. And L?
2, comma -4.
2, comma -4. Good job. Okay. Now I'm going to make my image. I have to multiply the x value by 2, and then the y value stays the same. So for J prime, I have to do -1 times 2, which is? Anyone?
Can you say that again?
Okay. I'm following my rule, which tells me to multiply x times 2.
That's -2, 2.
Good.
4, 2, and 4, -4.
Good job.
And in case you're wondering why I'm shaking, I'm also listening to music.
Okay. I was
My
wondering,
computer.
but I figured. Okay. All right. So all I did was multiply all the x values times 2. It's not hard, guys. I promise. This is not hard. Then I'm going to plot all those points. So I have -2, comma 2. This is my J prime. Then I have 4, comma 2. That's my K prime. And then I have 4, comma -4. And that's my L prime. Let me go ahead and connect all those points. Okay. Now, this one's a little bit different than the ones we've seen before. What is different about this?
The factor.
So it has a factor because, let's go back to the previous one. Same shape or different shape?
Different shape.
The different shape? The orange is a different shape?
I mean the same shape.
Okay, same shape, same size or different size?
Same size.
Same size. It's just in a new place. But over here, do I have the same shape or a different shape?
Different shape.
Different shape. Same size or different size?
Different size.
Different size. So is this rigid motion? Remember what I said about rigid motion? You guys all wrote it down.
Yes, it's a transformation.
Okay, but go back to the definition of rigid motion. Rigid motion is a transformation that changes the position of a figure without changing the size or shape. So let's go back. Is this rigid motion?
No. I mean, yes.
Yes, because it stayed the same size, the same shape. Is this rigid motion?
Yes.
Yep.
Yeah, good. Is this rigid motion?
No.
Why not?
Because it changed the size.
Because it changed the size. Exactly. Not rigid motion. But what's actually going on? How did it change in size? Did it get taller, shorter, wider, or skinnier?
Wider.
Wider. Good job. And when you get wider, that means that you're increasing the length to the left and to the right. That's what becoming wide means. So since I'm increasing the length from left
What
to
about the
right,
top?
did it get taller?
No, the top.
What do you mean the top? What do you mean the top?
It enlarged, right?
Right, it enlarged, but the question is, did it enlarge from left to right? Did it stretch to the left and the right, or did it stretch up and down?
Left to right.
Exactly, so that's what I'm saying. So since it stretched from left to right, that's going to be a horizontal stretch. And the factor is simply how much you multiplied by. So what did it multiply by?
2.
By 2. So this one was a horizontal stretch by a factor of 2. Questions, comments, concerns? All right, let's do the next one. Okay, so this is what I was saying before. In this case now, instead of them giving me the rule and then I have to draw the image, now they give you the image and you have to figure out the rule. So the first thing we want to look at is any patterns that you notice in the coordinate points of the pre-image and the coordinate points of the image. So does anyone notice any patterns?
It reflected.
How, okay, so you're looking at the actual graph. Right now, I literally just want to look at the numbers.
The X turned into negative.
Mm-hmm.
I'm positive.
X turned positive. So you could say the X flipped sign. What about the Y?
Stayed the same. Wait, no, it didn't. It didn't stay the same.
What happened?
It flipped also.
Also flipped. Good. Both of them flipped, right? Now we can look at the actual image or look at the actual graph. And looking at the graph, I want you guys to try and figure out for me, because this is where it gets kind of confusing. Is this a reflection or is it a rotation? Take 30 seconds to look at it. Don't worry about the numbers. Don't worry about anything else. Just try and see, is it a reflection or is it a rotation? All right. 30 seconds are up and I want to know what you guys think. So if you think this is a reflection, give me a thumbs up or a check mark or whatever you want to use. Reflection. All right. Now, if you think it's a rotation, give me a thumbs up or a check mark. Okay. There were a couple more for rotation, and I also saw it in the chat. A couple more for rotation than reflection. And if you chose rotation, you are totally correct. So can somebody tell me why they think it's a rotation and not a reflection?
Because reflection only reflects the x and the y stays the same.
So that was one thing you notice about it. What else? Oh, Perla says she flipped her phone. Okay, that's a really good point. Let me see if I can do that. So if I flip this, oh, it still stays the same. Darn.
Turn off what's the name? Per something orientation. Yeah, that.
I don't know if it'll. Nah, it doesn't do it. That's fine. Okay, well, in other words, you can kind of see how when you flip it over, if you like turn your head over, you see the same thing that you started with.
I had a little simulation in my head, so when I turned that over, it looked exactly the same.
Okay, so you kind of visualize it in your head. Another
Yes.
way to think about it is if this was a reflection, if it was a reflection, then you would be able to draw a straight line from connecting each point. So E to E should be a straight line, and they should never cross. So let's see if these cross. F to F prime, what happens? They cross.
It crossed.
D to D prime makes it even worse. They're all crossing. Since they're all crossing, that should give you a hint that you're not reflecting, you're actually rotating. It's turning all the way around. So really what's happening is E went like this. D, same thing, went like that. F, it went like that. So they're all kind of rotating around the center to get to their new place. Let me see if I can.
What I was saying.
Yeah.
If it would have been a reflection, it wouldn't have moved to the left or right. It just went straight up, but upside down or flipped upside down.
That's another way to, yeah. Let me see. I think I can do this. This will be really cool if I can. Yeah. Okay. So I can actually turn this guy around. Okay. So a reflection would have, oops. I don't know if I can do that actually. Oh, I can't flip it. Okay. I can't flip it, but I can show you how it's a rotation. So if I take my red triangle, and sorry, I know I'm making it bigger, but I can't help that. There we go. I literally flipped it over just to get to that same place. If it had been a reflection, I would have flipped it. It would have been like upside down. But I wish I could do that. I don't think I can. But I can show you, I can draw it. If it was a reflection, it would have looked something like this. Does that make a little bit more sense? That red one, that's a reflection. Okay. So now the last part of this is we actually have to make the rule. So the rule, remember how they do it. First you start off with x comma y, because that's what you're starting with. You're going to draw an arrow and tell me what happens to the x and what happens to the y. So what happens to the x? What happens to the x? Multiplied by -1. Yeah, it gets flipped. So instead of x, I'm going to write negative x.
All of them are multiplied by -1.
Yeah, same thing happens to the y. It goes from y to -y. And that is my rule for, this is a reflection. Sorry, I keep saying reflection. This is a rotation. And you don't have to know this yet, but I'm going to give you the full thing. This is a rotation of 180 degrees about the origin. Again, you don't have to know this part yet because we'll talk all about it next week. Origin. Oops. We'll talk about it all next week, but just so you guys know, that's exactly what it is. But for the purposes of what's going to be on your quiz tomorrow, for example, does anybody have a question on how to write that rule? Okay. Let's do another one.
Wait,
This
Miss,
ti-
Miss,
Oh, yeah.
when we do the test and the rule, you want us to write that x comma y?
There will be 4 answer choices and you have to pick the correct one.
Oh, okay. So it's not like we have to write it. Okay.
You just have to know which one's correct. Okay. Here's another one. Don't look too closely yet because what I'm going to do is I'm going to hide all of these numbers because I don't want you to look at the numbers. I want you to look at the graph. So look at the graph.
Yeah, I took a screenshot.
Look at the graph, and before you do anything, tell me, is this a rigid motion? So is it the same shape? I see some heads. Okay, yes. Same shape. Is it the same
Yeah.
size?
Yes,
okay.
Yeah. it
Good.
is.
So is this rigid motion?
C.
Good. So this is rigid motion. Now that I know it's rigid motion, I have to figure out, is it a translation? Is it a rotation? Or is it a reflection?
Translation.
Good. How do you know?
It's not being, what's the name? Rotated around 360 degrees, or yeah, what she said, teleported.
It's
Gotta
literally,
conjugate.
yeah, it's copied and pasted. They copy and paste it in a different place. So now what you want to figure out is the rule. First, or you can look at the patterns first. Look at the patterns. What happened? It moved up, down, left, or right. How many units?
It went to the right one and it went down 2.
Good. Right 1, down 2. The right, if I'm moving left to right, does that correspond to my x-axis or my y-axis?
Both.
Left to right.
Oh, hold up. Left to right, that's X.
That's x.
I didn't hear that part.
So this is x. Up and down corresponds to y.
Y.
So when I write my rule, same thing as I did before. I'm going to start with x comma y, arrow, and I'm going to say it like it is. What happens to the x? It moves to the right 1. So how could I write that using math? If x moved to the right by 1 unit, how could I write that?
Wait, what is that? Like negative X? Something like that?
It moved to the right.
Oh, to the right. That's positive. Well,
That's
1.
positive. Okay, positive
1.
1. So I'm going to write x plus 1. Then my y moved 2 units down. So how could I write that?
Negative 2. Or
Okay, but how would I?
y minus negative 2.
Y minus 2.
2. That's what I just said.
Just like that. And that's my rule. That's all it is, guys. Does it still confuse you all? And if it does, do you have any questions?
Autobots.
Which one is
Roll out.
the darker one?
Which one is the what?
Preimage?
Always look at the labels. So there's
Okay.
S, T, and U, and then S prime, U prime, T prime. So that's how you know when you see the primes, that's your image. If you're confused
Autobots.
about something,
Roll
ask a
out.
question, because I'm not going to know you're confused unless you ask. I'm going to assume we all know this perfectly, and I'm going to move on. Okay. Last one. This case, we do not have a graph, so we have to go off completely off of the numbers. So first, let's pick up some patterns. What do you guys see?
The x is still the same.
X is the same. How about the y?
Divided by 3.
Divided by 3?
Sorry, multiplied.
Multiplied by 3.
Multiplying right to left.
Good.
Oh, there's Perla.
Good. Multiplied by 3. So when you see that it's being multiplied, that should give you a clue as to what type of transformation this is. Since it's being multiplied, what do you think? Is it going to be a translation, rotation, reflection, or dilation?
Reflection.
Reflection. Wait, what was the question again?
Is it a translation, rotation, reflection, or dilation? I see
No.
Perla says enlargement. Remember, enlargement is the same thing as dilation. So if I say dilation, I also mean enlargement.
Dilation.
Dilation. Yeah. How do you know it's a dilation?
It's getting bigger.
It's getting bigger. Exactly. We're
Times
multiplying. Whenever you multiply, it's going to get bigger. Or smaller if you're multiplying by a fraction or a decimal. But either way, it's going to change the size of that image, that pre-image. So I know that this is a dilation.
So if the y is getting multiplied by some number, so it's a dilation.
If either of them is being multiplied, then it's a dilation. Yeah.
Okay.
Okay. So we know it's a dilation. Now let's write the rule. I start with my x comma y. I draw my arrow. And what am I going to write in the parentheses?
X times 1. Well,
Since x isn't changing, right? X is the same.
You just write x, right?
And then what about the y?
Times
X
3.
times 3.
And how do I write that?
Y times 3.
Would I write it like this? Y times 3? Or is there a nicer way to do that?
You put y3.
Not y3, but 3y.
Oh.
That's just how you do it in algebra. You always write the number first and then the variable.
And
that's
that's
it.
so extra.
It's literally not extra. Okay, that's my rule, and I'm done. Was this rigid motion? Perla saying no. Why not?
Because it's getting bigger.
So this is not rigid motion. All right. Last one, I think. Yeah. All right, same idea, but now I want you guys to try it on your own. Figure out the pattern, write a rule if you can think of one, and then try and see if you can figure out what type of transformation it is. Take 3 minutes to do that.
Miss, what did you say to do the rule?
Yeah, so read the directions. So it says write the rule and identify the transformation. And this last part is just saying, is it rigid motion or not?
Okay, I have the rule already.
Okay, good. Now work on the other parts. A minute left, and once you have an answer, you can send it to me in the chat. All right. All right, so let's see what's going on here. Patterns, what do we notice in the numbers? What happens
It's
to the
being
x?
multiplied by 2.
The x is being multiplied by 2, good. So x multiplied by 2.
And for some reason, I think y is being divided by either 2 or 1.
Good point. Okay, so it's kind of like because of the 0 there, it's kind of hard to tell because 0 just stays as 0. But remember that 0, when you multiply or divide it by anything, it's always going to stay as 0. So you have to look at the other points. So 2 becomes 1, and -2 becomes -1. So what is that? What does that mean? It's being good. I see in the chat, Perla said it's being divided by 2. Or you can say that it's being multiplied by 1/2, which is exactly what I was going to say as well. All right. So let's go ahead and write our rule. Well, before I write my rule, what do you guys think? Is this a translation, rotation, reflection, or dilation?
Can I use like some grid paper?
Some graph paper, you said?
Yeah, that.
That's a good idea. You should get some.
Okay, hold up, right back.
Maybe it's dilation.
Yeah, this is a dilation. How do you know?
Because it gets bigger.
It's getting bigger or smaller. Either way, anytime you're multiplying or dividing, it is changing in size. That's the most important thing. That's what makes it a dilation, changing in size. All
Yeah,
right,
I think I
so
might have asked this question already, but I need to make sure, like, whenever either x or y is getting multiplied, it's a dilation.
yeah,
Oh, okay.
yeah, exactly. Okay, good question. All right, so now let's write it down. So what happens to the x? How do I rewrite this?
Oh, or x. Can you like put x2?
X2 or 2x? 2x.
Yeah, 2x.
2x. Now my y, this is where it's a little tricky. I'm going to write it, we're always going to write it as a multiplication, even though it's dividing. But since it's dividing by 2, like Perla said before, you can write that as 1/2 y. Because 1/2 is the same as dividing it by 2. Questions on this one?
This seems easy.
Yeah, once you kind of understand it, it becomes a lot easier. Is this rigid motion?
Oh, well, I forgot about that.
Perla saying no. Does anyone else agree or disagree? Janelle's also says no. Okay, you're correct. Not rigid motion because it's changing in size.
Wait, can you explain to me what is rigid motion again?
Yes, rigid motion is when, okay, so anything rigid, let me look around. Let me see what I have in here. Okay. Okay, I have this llama. This llama is not changing in size. It is hard, it is rock solid, okay? It's not gonna change. This is rigid. When something is rigid, it means it's like made of a material that is not gonna change. This material, this is metal or ceramic, unless I like heat it up really hot or something, it's not gonna change in size. No matter where it goes, if I throw it across the room, it's not gonna, well, it might break, but if I throw it across at my bed and it doesn't break, it's not changing size. That's why it's called rigid motion. However,
Okay, so whenever something changes, that's rigid.
right. However, if I have something, I don't think I have anything around here. But like, let's say I had like a rubber ball. A rubber ball can get bigger and smaller because it's made of rubber. Rubber's not rigid, so that's not rigid motion. Does that make a little more sense?
C.
Awesome. Okay. This is a challenge question. There's only one of them. So this is the hardest one and the last one we're gonna do, which is good because we only have 10 more minutes. Okay, there's a long, long, long paragraph. Who would like to read it?
Me.
Go ahead, Tyrone.
Wait, hold up. Let me zoom in. Make a prediction. A landscape architect designs a flower bed that is quadratical. As shown in the figure, the plans call for a light to be placed at the midpoint of the longest side of the flower bed. The architect decides to change the location of the flower bed using the transformation XY. What's that symbol?
You can say
No.
becomes.
Becomes XY, negative Y. Describe the location of the light in the transformed flower bed. Then make the required calculations to show that your prediction is correct.
Awesome. Okay. So again, there's a lot going on. I am aware, but we're gonna break it down. I'm gonna erase this picture just so I have more room. But the picture is just showing you what is a flower bed. A flower bed is kind of like at JDD, how there's that garden in the middle in the courtyard. It's basically that. Okay. So, gonna highlight a couple of things. First, I'm gonna highlight the transformation because that's definitely important. So it's the flower bed that's currently on the graph is gonna move. And there's one more part to this that we have to figure out. What's the other thing we have to figure out?
Can you repeat that, Miss? I'm sorry.
Okay. I have to what's the question asking?
Describe the location of the light in the transformed flower bed.
Okay, the light. What does it say about the light earlier on?
Call for a light to be placed at the midpoint of the longest side of the flower bed.
There you go. So not only do I have to perform this transformation, after I do that, then I have to figure out where is the light going to be located. So
I
let's
see the midpoint right now.
right.
I think I can see it.
We'll have to figure it out once we get there, because first we have to transform it because it's got to move to a new location first. So we'll do that first. So my transformation tells me to change the sign of the y, right? So I'm going to go ahead and do that with each point. So I'm going to start with A, and I'm going to write this down because it's easier for me if I write it down. A begins at -3, comma, 1, 2, 3, comma 3. When I flip the sign of the y, it becomes -3, comma, -3. Just flipping the sign. So I'm going to go ahead and plot that point. -3, comma, -3, right here. Then I'm going to go to B and do the same exact thing. B started out at where?
+1, 4.
Good, 1, comma, 4. Flipping the sign of the y, this becomes y at 1, comma, -4. So I'm going to go ahead and I'm going to draw that in my figure. 1, 2, 3, 4, right here. This was A prime, this is B prime. Then let's do
I
C.
have a question.
Yes.
Wait, for number A, both of them are, wait, hold up. Both of them are negatives. Never mind. Never
Okay.
mind. I'm good.
Okay. So same thing with C. It started out at 4, 3. I'm going to flip the y. So this becomes 4, -3, which is over here. And finally, I've got D. D started out at -2, 1. So it's going to end up at -2, -1. All right, I've got my 4 new points. I'm going to connect them all. And based on what you guys see here, what type of transformation was this?
Reflection.
Good. A reflection over what?
Wait. Oh, over the origin.
So whenever I ask you over what, I want to know which line did it go over.
Wait.
Axis.
Oh,
Good.
yeah.
I heard someone say x-axis. Exactly.
was that
So-
Emily?
So reflection over the x-axis.
Okay, I understand now.
Good. All right. So we've done that. Now we have to figure out where's the flower bed. So it tells us the flower bed is at the midpoint of the longest side. So which one is my longest side?
From which one? The prime? I mean the image?
Yeah, in my new image.
Okay. Point C prime. I mean CD prime, I guess. I
Yeah.
don't know what to say.
Yeah, C prime, D prime. You can say C prime, D prime. That's my longest point, or my longest segment, right? So I need to know where's the midpoint of C prime, D prime. Or actually, the way you said it was actually even better, C, D prime.
So we read from left to right, right?
Yeah, in this case, it doesn't really matter which way you read it because it's just a line and you can read it from either direction. So this could be CD prime or DC prime. It's the same thing.
Okay.
All right. I have to find the midpoint, guys. What does that mean I need to use?
The midpoint formula.
Oh my
I
God,
know
I
the
can
midpoint.
hear,
I already
I can
figured out
hear
the
the
midpoint.
excitement in your voice. You're so
I already
excited.
know the midpoint.
You
The
do?
midpoint is, I think it's 1, 2.
1, 2
I think.
here?
Yeah, right there. I think.
Okay, but I need to find the midpoint of my image, not my pre-image.
It's the
So
same thing. It's mirrored, right?
yeah, but tell me the actual point.
Oh, 1, 2.
1, -2. Okay. So using just your eyes, you were able to see that, right? But I need to
Yes.
check using math now because I'm annoying.
It's X1.
So remember, this is x1 plus x2 over 2, y1 plus y2 over 2. Fill in. I know, y'all hate me right now, but I'm going to just plow right through. All right, so C and D, we already have these points right here. C and D prime. We don't need to find them anymore because we have them. So for x1, I can write 4, x2 is -2, so this is 4 minus 2 over 2. And for the y coordinates, I have -3 and -1 over 2.
That's 2 divided by 2.
Mm-hmm.
And the -4 divided by 2. 2 divided by 2 is 1. -4 divided by 2 is -2.
Good. So was Jalen correct?
Yes, he said that?
Yes. Yeah, he did.
Okay, good job, Jalen.
Yeah.
But don't trust your eyes all the time.
Yeah, Jalen.
It's always good to double check using the math.
I mean, don't you think I double check so I can make sure I'm actually right?
You got to double check for sure. Okay, that was a lot, I know, but how do we feel right now?
That was easy. Easy claps on my
The
name.
people who say it's easy are the ones who are struggling the day after. So, but careful with what you say.
Very
It's
true.
easy. It's easy. It's easy. It's easy.
Okay.
It's easy. It's
Tomorrow,
G-easy.
I'm going to be absent, which I think I mentioned earlier. I'm going to be absent, but there's no substitute or anything like that. So during the time that you're normally in class, so from 12:30 to
You
2,
live with your mother.
you have 4 things to make sure you finish. Number 1 is the diagnostic. So if you have not finished the diagnostic, you will work on that during class.
I can do that too.
If you're done with the diagnostic, then you can move on to your quiz. I will post the quiz on Teams in the morning, but it'll close at midnight. So you have all day to do it, but you should do it during class because you'll have time during class. The last thing is your Khan Academy assignment, which is also due at midnight. So this is your checklist for tomorrow. Take a picture of it or write it down.
Screenshotting.
Okay.
Wait.
So we don't have any new homework?
No, I have not posted anything new. Any other questions?
No.
Okay. Make sure that you do the Khan Academy because that's going to be what brings up your grade. You know that. Doing your homework is really important. And I believe that's all I have. Just a reminder about the homework. And that's it. All right? So I will not see you guys tomorrow, but I will see you on Monday. Please make sure you finish these things tomorrow. I don't want to have to call parents over the weekend, but I will if you don't do them. So make sure you do it. All right?
What are you gonna be doing?
Okay, guys. Have a good day.
Okay, goodbye.
Goodbye.
Bye.
Bye.